Hello, Accelerated Math 7-8 students. We are working in Module 14, and this is Lesson 4. Lesson 4 is called Solving a Linear Equation. Solving a linear equation. Our goal for today, solving a linear equation, our goal for today. Today we will practice solving equations with rational coefficients. Hopefully you remember what a coefficient is by now. We've been working with that terminology for a long time. The question, what must every equation remain in order for it to be valid? Remember, we're talking about equations. What you do to one side, you have the other. What is on one side of an equal sign has to be exactly the same as the other side in value. They don't have to look the same, but their value has to be the same. So you can have one expression that is equal to another expression, but the value in the end has to be exactly the same in order for it to be a true equation. Use logic, no math, to solve for the variable. So again, on this one, we're going to think logically. I know that's very crazy for a math teacher to say, use logic and no math, but we're trying to build on that number sense that you have. So looking at the first one, 4 times what number plus 1 gives you 13? Everyone already in the room should be done already. You know that 4 times 3 is 12 plus 1 is 13. So very quick, x has to equal 3. All right, so now the next one is a little bit more tricky, okay? We have 3 times the quantity of 4x minus 9, add 10 to that. That is all supposed to be equal to or the same as 15x plus 2 plus 7x. Trying to figure that one out in your head is a lot more complicated, okay? And so the whole point of this lesson right here is trying to teach you that sometimes mental math is very doable, and then other times mental math is just completely overwhelming and kind of daunting. Like it's going to take you forever to try to do a trial and error to make some of these work out. And so it's pretty important that if we hit this situation where we can't necessarily do it in our head, that maybe we have a backup plan. I don't even know what the value should be over here yet, because this over here is very vague as well. And so doing a trial and error literally could take me hours, whereas this was a matter of seconds to figure this one out. However, since we don't have a complete answer, like 13 was very easy, but this has unknowns on both sides, so it's going to be a lot harder. And it's going to take a long time. And one of the things we know about mathematicians is that once it starts to take too long, people get frustrated, right? And then they start wanting to give up. So there's something else that I want to show you, and we'll come back to this in just a minute. But sometimes it's easier to solve equations, linear equations for that matter, because remembering that the value of the variable can only mean one amount, sometimes it's easier to have some steps to help us. All right, so let's take a look at this. This says 4 plus 1 is equal to 7 minus 2. How many of you think that that's a true statement? And if you are shaking your head, yes, duh, Mrs. Nelson, 5 equals 5. Okay, well then let's see what happens if we add 3 to both sides, to each expression. So far we have 4 plus 1 equals 7 minus 2. So what they're asking us to do to check and see if it would still hold true is what happens if you add 3 to both sides. So I'm going to take 4 plus 1, and I'm going to add 3 to this side, and then I'm going to maintain the idea that this always has to equal this. Well, then that should be true that if I take 7 minus 2 and then I add 3, that I should still come up with the same answer. All right, so 4 plus 1 is 5, plus 3 is 8, 7 minus 2 is 5, plus 3 is 8. Okay, so far so good. Now it's telling me that I'm going to add 3 to the left side and 2 to the right side. So I'm going to change colors so we can keep track of this. So I'm going to take add 3 to the left, and then add 2 to the right, and then see if it's true. So I have 4 plus 1 plus 3 plus 3 should be equal to adding 2 to the right side. So 7 minus 2 plus 3 minus 2. Is it true? Well, 4 plus 1 is 5, plus 3 is 8, plus 3 is 11. 7 minus 2 is 5, plus 3 is 8, minus 2 is 6. They are no longer even, so it would not be true. Okay. Now, let's see if we, it says subtract 6 from both sides. If we do 6 from both sides, I'm thinking that if we just subtract 6 from both sides on this one, we're going to notice that it's still not going to be true. And let's check it. Okay, so 4 plus 1 plus 3 plus 3 minus 6 should be equal to 7 minus 2 plus 3 minus 2 minus 6. Okay, let's see what happens. Ready? 4 plus 1 is 5, plus 3 is 8, plus 3 is 11, minus 6 is 5. 7 minus 2 is 5, plus 3 is 8, minus 2 is 6, minus 6 is 0. So again, not equal. Okay? So basically, the pattern that is so important in this experience is that the minute you do not maintain the same change on both sides of the equation, they're never going to be equivalent again. So that's why that rule, what you do to one side, you have to do the other, is so, so important, because once it's not, these will never measure up again. Okay? And that's what the whole point of figuring this out. So I have to say that we have already learned of the steps that help us solve it. And so I want you to, in this next section, it's asking you to solve. And up at the top it said to use no math, which for the very first one was easy. Second one was scary. So let's go back to the second one, and let's talk about what we could do to actually figuring it out. First things that I would like to do is you've got to make sure that you don't have any distribution going on. And we do have some distribution going on, so before we can go any further, we actually have to distribute that 3. So 3 times the quantity, 4x minus 9. So basically what that means is I have 4x minus 9, 4x minus 9, 4x minus 9. That's what it means. I'm taking 4x minus 9 3 times. So if I have 4x 3 times, what do I actually have? I have 12x. Nice job. If I have 3 9s, that's 27. So now this little section right here has become 12x minus 27 plus 10 is all equal to 15x plus 2 plus 7x. Okay? And so now, if we're looking at it, the next step that I've taught you in the past is you need to combine like terms. Okay? So on this side, I would say that the like terms that you have are the constants. Right? And on this side, I would say that the like terms that you have are the variables. Everybody see that? Okay. And so let's do that. We know that 12x minus, we're writing 12x minus 27 plus 10 is 37, right? Equals, and then instead of it being 15x, it's now going to be 22x plus 2. Okay? Does everybody see where we're at so far with that? Combining like terms. All right? And now, the next step is, we've had this conversation quite a few times, is in order to figure out what x is, x has to be on the same side of the equation, because right now we have x's on both sides, and that makes it kind of tricky. And so we've got to get either these x's to join over here or these x's to join over there. And if you remember, in order to unhook this, because these 22 x's right now are hooked to these 2 positives, and these 12 x's are hooked to these 37 negatives. And so we've got to unhook them somehow. And so if you're remembering, when you unhook them, you have to do the opposite. So right now, these are positive x's, and these are positive x's. To unhook them to create a zero pair, you have to do the opposite. So if I make these negative 22x's, that means they're going to be negative over here. Whereas if I make these negative 12s, when I come over here and I take away those negatives, I'm going to be left with positive x's, which is my preference. So I'm going to subtract 12x from this side, creating a zero pair. And what you do to one side, you have to do to the other. So I'm going to subtract, and I get 0, 1, and x. So I'm left with 10 x's because those were negative x's, and we combined them up, and we're left with those. So now I have negative 37 equals 10x plus 2. And now I can use my BU. All right? So my variable is x. First thing that I did to x was I multiplied it by 10. Second thing that I did to it is I added 2. So now I'm going to subtract 2. I'm going to divide by 10, and I'm going to be left with x. So subtract 2 from both sides. Okay. So this becomes a zero pair. I'm left with 10x on this side, and now I have 37 negatives and 2 more negatives, so that gives me 39 negatives, right? And then I know that x, because I'm going to divide each side by 10, I know that x is going to be negative 3.9. And that's the answer of x. How many of you ever could have thought of that in your head? Not this old lady. Not this old lady. Okay, so it's very complicated. All right, so you have 3 problems down here that I want you to remember all of this. Distribute first if you have distribution, combine like terms second, create a BU chart, and then solve for your variable. That's what I want you to do for these problems down here. Solve the linear equations. Make sure you combine those terms, get all of the variables on one side, and then use a BU chart. I want you to give it a try, and I'll be checking it with your notes tomorrow. All right, so back up at the top. Today we will practice solving equations with rational coefficients. That's what we're doing. What must every equation remain in order for it to be valid? It must remain balanced, equal, same as, okay? And that's all I've got for you today. All right, have fun solving it, and I'll see you tomorrow. Bye.